Today we're going to start talking about combinatorics. That's the unit we're going to begin today. And combinatorics is a fancy word for counting. What we're going to be doing in this unit is learning how to count certain things. That sounds kind of like a joke, but it isn't. It's actually pretty tough. We'll be doing things like learning how to count, for example, if you have 10 different students and you have, 15 different desks, and how many different ways can you place the students in the desks, right? That's a counting problem. The principal tool that we're going to use in counting is something called an algorithm. You might have heard that word before in programming or computer science. An algorithm really is just a step-by-step procedure. Step 1, do this. Step 2, do that. Step 3, do that. It's like a recipe. And what we're going to be doing is, in today's lesson, we're not really going to be counting anything. We're not going to be using any numbers, but instead we're just going to be thinking about algorithms. So I want to begin with a definition, which I have here. So a counting algorithm is a step-by-step procedure which generates or creates the things you're trying to count. Okay? And that's a bit abstract, so let's see an example. So example 1. A fast food restaurant offers combo meals which consist of a sandwich, a side, and a drink. There are many choices for sandwich, drink, and side. Write a counting algorithm which generates all possible combo meals. So what that means is I want a step-by-step procedure which, if followed, would create every conceivable combo meal. So here's one possible algorithm. Step 1, choose your sandwich. Step 2, choose your side. Step 3, choose your drink. If you make those 3 choices, you have definitely specified a combo meal. Okay? So it's a bit like if you ran this algorithm over and over and over again, it would be capable of generating every possible combo meal. Okay? That's what I mean when I say a counting algorithm is a step-by-step process which generates the things you're trying to count. We're trying to count combo meals, and this algorithm generates all possible combo meals. As I said, we're not really counting anything today, just writing algorithms, so that's the end of the problem. Just a quick note, this is not the only algorithm, right? Here's a different algorithm. You could instead, step 1, choose your drink. Step 2, choose your side. Step 3, choose your sandwich. It's a very similar algorithm, but it's technically different, right? That would also work. Okay, well, let's have a look at a more interesting example. Example 2, suppose there are 6 students and 4 desks in a room. Write a counting algorithm which generates all possible seating assignments. So obviously only 4 students can actually be seated. The remaining 2 will just have to stand. So here's one way of doing it. Okay, we've got 6 students, 4 desks. Here's an algorithm which will generate or create a seating assignment. Step 1, choose who sits in desk number 1. Well, of course. Step 2, choose who sits in desk number 3. Step 3, choose who sits in desk number 3. Step 4, choose who sits in desk number 4. That would surely generate a seating arrangement. So that's a counting algorithm which will generate all possible seating arrangements. Now, what's interesting about this example is that there is actually a different counting algorithm that you could write down, one that is maybe substantially different, and it goes like this. So, of course, we know that 2 people are going to be left standing. So if you liked, you could begin by deciding which 2 students are going to stand. Maybe you start by picking your least favorite 2 students. So step 1, choose the 2 students who will remain standing. Okay? And now, after you've done that, there will be, of course, 4 other students, right, who are still unaccounted for. Let's give them some names. Suppose the other 4 students are Billy, Bob, Bart, and Blob. So we have to decide what to do with those people. Your next step might be choose where Billy sits. And the third step might be choose where Bob sits, and then choose where Bart sits, and then choose where Blob sits. And that would also generate a seating arrangement. I think this algorithm is a little bit less natural, but you can see that they're sort of fundamentally different. In this first algorithm, what we're doing is we're sort of picking a desk and saying who sits there, right? In this algorithm, for the most part, we are picking a person and saying where do they sit. Okay, so it's kind of two ways of doing it, and it's important to be sort of thinking about both of them, because sometimes one of those strategies is more helpful than the other. Okay, so last example, a permutation of the word math is a rearrangement of the letters. For example, THAM, TAM, MHTA are all permutations. Write an algorithm that generates all permutations of the word math. So here's one way of doing it. Step 1, choose which letter comes first. Right? Step 2, choose which letter comes second. Step 3, choose which letter comes third. And finally, choose which letter comes fourth. Right? It's a little bit like we've got 4 blank spaces, and we're sort of saying which letter goes here, which letter goes here, which letter goes here, and so on. You could do it a different way. You could instead say, step 1, choose where the M goes. Step 2, choose where the A goes. Step 3, choose where the T goes. Step 4, choose where the H goes. That would be a different algorithm, and it would also work, right? It would also generate all permutations. Okay, so that's all I'll say. Just one quick comment in these exercises. I ask you to write down a counting algorithm, for each of these situations. I don't want you to feel like you have to write down full, complete sentences for each of these things. It's kind of a lot of writing. You can kind of be as brief or abbreviated as you want. I don't want you to write paragraphs and paragraphs. As long as you're clear in your mind about exactly what each step is doing, I'm okay with that. Okay, that's it.